Okay, so today we're talking about recognizing functions through graphs. We saw last week in section 1.1 recognizing functions through the tables, and now we're going to look at things more graphically and kind of use a similar process and identify the type of graph, identify the type of function from the graph. So our essential question here is describe the different features of the graphs of linear, exponential, and quadratic functions. So again, just real quick, recall that with a linear function, when looking at the data data shows a common first difference. When looking at a quadratic function, the data shows a common second difference. And when looking at exponential function, the data shows a common ratio. So we're multiplying by the same thing to get from one number to the next. So for GP number 1, we have no vocab today. For GP number 1, we are recognizing functions from graphs. And this is the title of our notes as well. Sorry about that. So the directions for GP1 are to use the graph and data to determine, that was some thunder out there just now, to determine the type of function the graph represents. Describe how you know. With 2 reasons. And then lastly, write the domain and range of the graph in inequality and interval notation. Now, inequality notation is the notation that I showed you guys in the review notes. So that should look familiar to you. Interval notation, it looks a little bit different, and I think that's the notation that the majority of you are familiar with. So we're going to talk about the difference between those, and we have to make sure that we're paying attention to the directions and whether it's asking for us to write the domain or range in which notation, and make sure that we're doing that correctly. Okay, so I have also included some printables. So if you want to pull those up, you can go ahead and print out the graphs that you're going to need for this set of notes. So the graph that we're going to use to start with should look like this one here. So go ahead and pull that graph and go ahead and cut it out. This is the graph we're going to use for question A. right, so given the graph, the first thing we want to do is to take a look at the data. Now, we want to create a table of values like we used in section 1.1 to just kind of analyze the data and see what type of function we're looking at. Now, as we become more and more familiar with the graphs of these different functions, we'll be able to analyze and look at the picture and be able to determine the type of graph. But we're going to do both today. So the first thing I'm going to do here is to create a table of values. So I'm going to add to my toolbox, create table of values. Now, if you want to abbreviate that, you can call table of values TOV for short. So what we want to do is look at our different x values. And so we have points at -5, -4, -3, and -2. So those are the x values that I'm going to use here. And my y values, now here I labeled this one because it was a fraction, but this is 1/3. The y value for 4 is -4 is at +1. For -3, 1, 2, 3. And for -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if we're looking for the common difference, you're going to see that the difference between these two numbers is 2/3. From here to here is 2. From here to here is 6. So we can start by looking at that. And then if we're looking at the difference between these ones to see the second difference, this would be 1 1/3, and this would be 4. So clearly, this table of values does not have a common first difference, nor does it have a common second difference. So from there, we want to take a look and see, is there a common ratio here? So if we're looking for a number that we're multiplying to get from one value to the next, 1/3 times 3 would give us 1. 1 times 3 would give us 3. And 3 times 3 would give us 9. So this is the common ratio of our data. So to answer the first part of the directions, it says to use the graph and data to determine the type of function the graph represents. So this is an exponential function, because the second part of the question says to describe how you know with 2 reasons. So first, we know because from the data, we have a common ratio. So I'm going to say it's an exponential function because the data shows a common ratio. And then the second way I want you guys to kind of justify how you know what type of function it is by looking at the graph. So again, I want us becoming more and more familiar with the shapes of the graphs of different functions. So if you look at an exponential function, you'll see that it's really small here, but then it gets really big really fast. And that's what we refer to as exponential growth. And that should be something that you kind of looked at in Math 1. And so what we're going to mention here is that because the data shows a common ratio and the graph grows rapidly. You might also have exponential decay, which is basically going to look the same way but flipped. So it's really big on the left, but then it gets really small really fast, or it decays really fast. So those both show an exponential function. So that's what we're looking for. So we make a table of values. We want to check for the ratio and or differences. Depending on what type of function we have, we'll determine what we find. And from there, we can determine the type of function. Abbreviate that. And then from there, the last thing that we were asked to do in the directions was to write the domain and range. So down here, we're going to start with domain. Now remember that domain shows all of our x values. And we have specifically cut this graph down to go from this value here to this value here. And when we read and write the domain, we read and write it from left to right. So the very left side of our graph is at -5, and the very right side of our graph is at -2. So our graph begins at -5 and our graph ends at -2, and our x values are from -5 to -2, but everywhere in between. So -5 is less than or equal to x, which is less than or equal to -2. Now this is what we refer to as inequality notation, because we have those inequality symbols. I've also asked for you guys to write it in interval notation. And when we write our domain and range in interval notation, we're going to use the same numbers that we have here in inequality notation, but we're going to use brackets instead of the inequality. So we use the brackets that look like this. Now, these are what we call closed brackets because our graph exists at -5. There is a point at -5. So the brackets include that value. And we're going to talk a little bit more on Wednesday, actually, about when to use something different than that. So it is closed at -5, and it is closed at -2 because, again, we have a point at -2, and we just separate those with a comma. So when we're writing the domain in interval notation, we're going to use the brackets. But again, the same values that we saw in our inequality notation. So for the range, we do the same thing. But remember, for range, we're looking at the y values. So that's the very bottom of our graph to the very top of our graph, and it's those y values. So this is the very bottom, and our y value at that point is 1/3. So the range from bottom to top, because remember it's from the smallest value to the largest value, is from 1/3 all the way up to the top y value, which is a +9. And our y value goes from 1/3 to +9, and it's everywhere in between. So 1/3 is less than or equal to y, which is less than or equal to 9. Then we want to take that and do the same thing in interval notation. We use those brackets. We have our lowest value all the way up to our highest value. And that is our range in interval notation. The last thing I want to include in the toolbox is that the exponential function will show rapid growth or rapid decay. Exponential graph. And that is it for our first graph.